In part two of this lecture, we're going to talk about the three upcoming waves of IT innovation and the three patterns that are emerging beneath the glut of emerging technologies. And it's going to impact all industries, but I think predominantly it's going to make huge impacts on the IT laggards, government, healthcare, and education, which are third of the global GDP. So let's look at the three. We are looking at the first one, which is going to transcend the physical digital boundary. And it's essentially 3D printing and robotics. Next is the overlay of physical on digital. And essentially we're going to look at Internet of Things, augmented reality, and artificial intelligence. We'll go into detail about that. And the last is the scale, and the scale is going to be either in huge scale or it's going to shrink things. The things which we are used to are suddenly it's going to be expanded in scale or suddenly become very tiny. And we'll go through each one of them. So as we talk about it, we'll see there's a huge productivity bump which will create a bunch of new losers and winners. So the first wave is transcending the physical digital boundary, and this is where it actually kind of destroys this clear-cut boundary where physical world ends and the digital world begins. So let's look at the two. 3D printing. So currently we are using the internet. We're going to send digital signals which through a 3D printer, which will then create the object we need. So unlike conventional manufacturing, where you chip away at blocks of material to create an object, 3D printing or additive manufacturing prints layer on layer of diverse material fused by laser to create an object. So unlike digitization, which converts atoms to bits, 3D printing actually converts bits to atom. And 3D printing is still in its nascent stage, but think about the implications of it. Zero transportation costs because products are shipped over the internet, materialized where they're needed. Economical production of one customized unit instead of a mass production of clones. Reduced need to hold inventories of parts and products, and further erosion of geography. A product can be delivered from anywhere to anywhere. It is weakening the constraint of the physical form. So we talked about how peer-to-peer service is now common. You look at your Uber. Uber kind of puts itself as a intermediary between drivers and passengers, and they're like, we don't really own taxi drivers. That's what they're saying, we are a broker here. Or Airbnb. So these were the digitization of service, but now we are looking at digitization of manufacturing and then the peer-to-peer. I mean, so if you have a design individual, you don't have to build a company. You could sell your design on the internet, and so you could have peer-to-peer manufacturing. I mean, of course, we are in the very nascent stage, but the promises of 3D printing are enormous. So remember, this is a question mark. There's no need for us to essentially freak out and say it's all gone. No, there is still mass production, and I'm pretty sure we'll see multiple layers. But let's look at some of the initial applications. Now we have digital scans of patients' teeth can produce tens of millions of dental implants. There's custom-shaped hearing aid, which are made specifically for each individual. GE uses 3D printing to build fuel nozzles for its jet engines. Airbus for airliner cabin fittings. Contract manufacturer Light On for printing. So printing, they print about 10 micron sensors and antennas directly onto circuits. Auto industry is using this to prototype cars in physical and digital world at the same time. As a designer reshapes 3D printed model by hand. Scanner detects and changes and updates the digital model that optimizes for weight reduction, varying tensile strengths in different parts of a single component. It even adds an undo button in the physical world. 3D printer can reverse any human misstep directly on the physical model. In long term, future products such as cars could get physical upgrades just as smartphones now get software upgrades. So a lot of potential here. Now let's look at the other one, emerging technology of robotics, which is automating repetitive human jobs, factory work, driving trucks, serving food, and robotic automation increases productivity. And you can see here different companies, robots per worker. You can see it's huge in Korea, Germany, less in United States and China. So there's a huge productivity bump by using robots, and it substitutes for human labor. Now, there are a bunch of new generation of factories called dark factories where you have only one human being who does the work of six. In fact, there was a documentary on a BMW factory in Germany which has 3 workers. That's it. And they're maintenance workers, and everything else is done by robots. Now, robots doesn't have to be in physical form. You could use Siri is a robot, Alexa is a robot. And so in combination with artificial intelligence and natural language processing, they substitute human cognitive labor to do customer service jobs, perform bookkeeping, control self-driving cars. Now look at self-driving cars. The Boeing 787 Dreamliner needs a pilot only for 7 minutes of its 15-hour flight. So this is an interesting wave. Now robotics has automated a lot of manufacturing. We've heard this whole term about how our manufacturing jobs are shipped abroad to China and other places. Actually, that's not true. Manufacturing has already come back to the United States in the last 10-15 years. The difference between the manufacturing of old to new is the reason why there are no manufacturing jobs is robots. It's a lot of the jobs are being automated, and so the labor level needed, the skill level needed is a much higher. And so the old job where you would go to a factory and turn a wrench 8 hours a day is pretty much gone. The second one is overlaying the digital on the physical. The second wave of overlaying digital thread on physical assets and human beings to wring more productivity out of them. Physical objects acquiring digital essence is creating entirely new way for firms to interact with customers. So here are 3 different where you're morphing old school industries into information business. The first thing is Internet of Things, where you are not is displacing the Internet of People. So now we're still in the Internet of People, and we are actually looking at cheap sensors which can connect to the internet on ordinary objects. It provides context, location, temperature, movement, brightness that are historically unavailable to firms. This opens up opportunity for firms to figure out creative business uses for contextual data. For example, modern GE jets has hundreds of sensors that continuously capture data of engine heat, fuel consumption, blade wear, operational environment, and it actually collects one single flight from New York to Chicago collects 60 iPhones worth of data, 1 terabyte, which GE uses for preventive methods. Similarly, FedEx places a device about the size of a smartphone on sensitive packages, and it can remotely monitor its location, temperature, and light exposure. Norfolk Southern is embedding IT throughout its railroad to increase average speed and reduce downtime. So this is definitely connected sensors is becoming more and more a part of reality. Next, we will look at augmented reality. So in augmented reality, we're superimposing information on physical objects to aid human decisions. This could be your Google Glass is augmented reality. And Boeing assembly manufacturers use virtual reality glass to show them animated pointers to proper drilling locations of airplane parts. We have now, you know, car windshields which actually enhance what you're seeing. There's Warby Parker, which lets buyers try on glasses using their own headshots. Smartphones that instantaneously translate street signs from one language to another. So there is a whole bunch of options. Here is an example of using selfies to reduce online clothing. And the last part which we are looking at is artificial intelligence, which allows human beings to mimic human reasoning. And we are using a methodology called deep learning, where unlike program software, human beings put the rules down. In deep learning, huge amounts of data is passed over, fed to this algorithm, which then discovers very complex rules beyond human ability to digest examples. So this is a huge move forward. And this has been around since 1950. And the reason why this has really taken off now, machine learning is not something new. When in 2002-3, when I did my computer science, master's in computer science, we were working on machine learning. But the big advantage now is big data. We have a lot more data than we had before, and then really powerful processors which can actually allow you to look at tagging. For example, Facebook uses tagging and uses algorithms to figure out rules. And so this really helps our cancer cells in medical images. So what AI is going to do is, just like robots took away a lot of blue-collar jobs, any kind of routine white-collar jobs are now vulnerable to AI. Already X-ray technicians are being replaced by AI. Paralegal jobs could be in danger. And then we are looking at data-intensive jobs in insurance, finance, manufacturing, healthcare, anything which is repetitive. So let's say you're opening up an Excel spreadsheet and you are constantly doing step 1, step 2, step 3. Now that can be automated and replaced by an AI machine. So we need to upgrade our skills, where we need to do things that the machine cannot do. AI does amplify humans' cognitive capability, allowing one individual to do what is previously required by many, and therefore it is important. For example, AI does need human judgment and feedback to improve itself, and a lot of the new skills are needed for human beings to do things machines cannot do. Wave 3, which is transforming scale. The third wave of emerging technologies is to either create a huge network or a very tiny version of familiar activities. And let's take the gigantic first. We have big ecosystems such as iOS. Imagine an iOS system of more than 200,000 firms, billions of users, but outside the technology industry. This kind of is like the Star Trek Borg. We have multiple business ecosystems if this is around a firm, but if it's around individuals, it's called crowdsourcing. We already have crowdsourcing in venture capital. And this is shifting competition from firm to firm to ecosystem against ecosystems, which means that standalone firms like Walmart are struggling to compete against rival ecosystems like Amazon. Now remember, when you buy on Amazon, you just don't buy Amazon products that Amazon sells. Other sellers are on Amazon. So they're becoming increasingly engines of innovation in diverse industries such as consumer goods, manufacturing, retail, automobile, healthcare, etc. Now from the huge to the tiny. So we are now, IT is also making it possible for smaller, and it's a shorter history there, but you're using, let's take the example of a small micro camera, which is in a capsule which you swallow, which can actually take pictures of your entire stomach and intestine. And this is now reality. And so instead of going through an endoscopy, you can take this little capsule, and it'll actually take a look at, it'll go through your entire gastrointestinal system and take pictures of it and send it back to the doctor to take a look at, to see if you have an ulcer, you have a blockage, or anything like that. Blockchain is another example where you have elaborate decentralized records stored on different computers worldwide. That makes financial records and medical data more tamper-proof and fraud-proof, so it does increase the security there. And we're also looking at untapped potentials of machines' growing ability to talk to each other. Let's take the example of driverless cars, which can self-assemble into a convoy using car-to-car networks. Once we have all cars are driverless, these cars can talk to each other, broadcast their speeds, location, steering wheel position, brake status, constantly reducing traffic, but also increasing traffic flow. So this is the third wave of the transforming scale. So in summary, we saw that firms stumble with emerging technologies because one, they misjudge the hyperbole for substance, forgets that it's not the technology but business application creates value, and sometimes they're just too early or too late. The signal to noise ratio clouds judgment, and therefore use the three lenses to figure out whether this is really important. There are three waves which we talked about, three waves of technology. One that transcends physical to digital, second that overlays a digital code on physical assets and human beings, and finally transforms the scale from tiny to gigantic. And so we come to the end. We first talked about this unicorn of cheap yet strategic IT, and we can make this unicorn a reality when non-IT managers contribute to strategy. Again, if you're really interested in this emerging technologies, which I think is such an important part of a manager's work, we do have a certificate program called Certificate in Managing Emerging Technologies, and we have it's a workshop every fall, one day from August to December, and we have people from University of Maryland College Park, from the NSF, from the Pentagon come to talk to you about different aspects of brand new technology, and it is specifically for non-IT managers to enhance their understanding of IT so they can have a conversation with the IT managers.